thing now. So please fill in your EA groupings. And then after that, let's open up Grasshopper. Let's open up Rhino first. So when you first download this file from Rhino, you will see this. It's called the start file. It will be located at the top of lesson 8 on top of these, let's say on top of these screenshots. I will explain the screenshots a bit more, but basically when you open the file, you will see the first screenshot, which is this one. Okay, so generally for this class, what we will be doing is that we will be mapping this surface onto this surface. And what this surface is actually we're using the same site. We're using the same site as the repeating frames, and actually, you know, in CA3. So this will be CA4, and we will be more focusing on the surfaces. Okay, so I believe most of you will be already on this screen, and it's not that hard to get to this screen. So what we first have to do is the following. We have to type package manager. We have to type package manager into the command. So package, and then if you type PACK, it will already show up. So this is a really good way to install plugins. Because in the past, how we would install plugin is to go to Google, and then Google, and then we have to type food for Rhino, right? Food for Rhino. So these are some of the things that we told you before. Now there is a new way after Rhino 7 got a big update. After that, we are able to actually install plugin and multiple plugin. Not every plugin is here, but there is a lot already available here. For example, we are going to search for Lunchbox here in our package manager. So if you type Lunchbox, it will show up here, and then I will, in the meantime, I will also do Lunchbox here. So there are two ways of this is the slow way of installing something, right? Lunchbox and then download. I believe you have to log in to download, but here in Rhino, when you search Lunchbox, click on this, click install. It should already install. It should already be done. Okay, successfully installed. And then it will ask you, please restart Rhino. So please restart Rhino as it said, so that the installation would take effect. Okay, so by now you should have installed Lunchbox and then reopen Rhino. We should put this Lunchbox thing aside first, as I will also get to it in the later stage of this tutorial. It won't be very evident at first, so I will start by not using Lunchbox yet, and then very quickly I will jump into using that. Okay, so this first part we will be able to do without any plugin. So don't worry if you don't have it yet, but in the next part I will start using plugins to make it faster or make it easier for me to show you. Okay, so basically you have two surfaces, right? One surface here, one surface here. What I just said is I want to map whatever this something here, whenever there's something here, let's say there is a word AV3 here, I want to be able to map it here too. So this is basically what we try to do now. The other day, last week, I taught a lot about how to map certain things here by using the point cloud, by using the populate geometry component. So I will also use that. But bear with me. I will go through the most simple example first. Okay, so basically what we will now be following is this following script here. Okay, so I will be using the geometry. I'll be using the geometry, and then I can also display draw full names. So you see the full name of this. And then actually the most important is this surface morph. Okay, so let's do the surface morph first. Surface morph. So there's this with this icon. Basically what this does is try to let's go one by one by saying what it does, right? So of course, when you want to, like I said, right, when you want to morph, I'm just sketching what I had before the screenshot, right? If we want to put this surface or put something flat surface like an AV3 onto a three-dimensional surface, of course, we will have to input the geometry. So the geometry in this case would be AV3. And then AV3 lying flat on a piece of let's say piece of plane. And then it would ask for the reference plane, and then it would ask for the surface. Very simple, right? 3 inputs. One input, what are the objects that you want to transfer onto a three-dimensional surface? Input 2, what is the initial surface? What is the original surface? Input 3, what is the surface that you want to map it on? Very easy, right? These 3 are basically the input. As for what UV domain is, I will try to explain it in a while. So let's first start let's start the process first, and then we will explain bit by bit. So right now I am just drawing something to map on this surface, right? There's this surface here, there's this surface here, and then this is the geometry. Okay, so let's start by you can draw anything. In fact, you can type, you can do text and then AV3, but then a text won't be visible. So you have to explode it. You have to explode it so that it I have to rotate it to sorry. ROT rotate. So you have to also rotate. Oh no. Okay. Okay. Actually, gumball is better. Okay. Anyways, you can draw anything, put it here so that it can be referenced onto the plane. So let's do select one. No, select multiple geometry. Select multiple geometry. Put this geometry in here, basically where it says geometry, right? And then what we would need to do is we would need a surface, I believe surface. Let's do surface. Let's do all of them as geometry. So geometry, geometry, and geometry. So, but then you have to reference one here. you have to reference this one here too. Okay. So basically, when you cycle through, you should have one is the AV3. You can rename it AV3, or you can rename it curve, your own curve, give your curve a name. And then you can do reference here. And then this is the curved surface. You can name it anything just so that you remember, right? So you know that this is the reference plane, this is the curved surface. Okay, so we kind of have three things for them. And then now it's asking us for UV and W data. UV and W data, we have to input this domain. So I can also use construct domain rather than just typing 0 to 1. So construct, oh wait, right, construct domain. Oh yeah, you have to type the construct domain without the square or cube. So basically, this is what it will do. It will construct a domain from 0 to 1. So you can also type in the panel 0 to 1. I think it's 0 space to 1, 0 to 1, or like this, or you can use the construct domain. In fact, it should give you the same thing, and you can change the domains here. Okay, and then let's plug it in and then see what happens. It's still giving me red. So it's still giving me a problem. It's saying reference space volume cannot be 0. Okay, so it's saying that your reference, like this one, basically this one, the space volume cannot be 0. So there's some workaround around this. This is due to the fact that it has no volume, it has no height, it has no z-axis, so that it doesn't know how to read if you are sort of morphing it onto another surface. It has no reference of what's the direction and what's the height of it. So we have to basically, what we need to do now, we have to give it some height. And this is just basically how this sort of component works. So let's do extrude on this surface, and then we extrude it in the Z direction. So basically, it encounters a problem of input, so we have to make a workaround. Okay, so we extrude it, and then we extrude it to the C direction by 1. So we did an extrusion in Grasshopper, and then we feed it back to the reference. Basically, this is the workaround, right? This piece here is the workaround of an input problem. Okay, but then look at what we have right now. Look at what we have right now. What we have right now is this, right? So it's wrong, right? It's obviously not mapping AV3 as we wanted it to be. It's giving me this sort of error of AV3 being sort of inverted or the other way around. Okay, so that's a problem, right? That's a problem where it looks like we're morphing, but then it's the other way around or upside down. Okay, so how are we going to make it work? The way that we're going to make it work is by reparameterization. So reparameterization is a difficult concept in Grasshopper. It involves a lot of understanding, but basically, let me try to explain it with a curve. So when you have one curve, I'm just going to do some explanation here. When you have a curve, and when you set one curve, the curve will have, and then we will do, I believe, analyze. Is it analyze curve? Analyze curve. Curve analyze. Curve analyze. Is it curve analyze? Curve analyze. Wait. Okay. Let me search it up. Analysis. I forgot how to do an analyze curve. Utility. Analyze. Wait. Okay, I don't remember. Okay. Anyways, this video should be able to answer me. So you can take a look at these two videos. But basically, oh, it's really loud.
Is evaluating a curve at a location. And let's cover first type of curve that we can have in Rhino. So we can have a first dimensional curve, which is basically a straight line, or this can also be a polygon that has a linear interpolation between points. We can also have arches. That is a two-dimensional curve with 3 points. Or we can have nerve curves that have more control points, or what we call as TVs. And there's a quadratic function that interpolates between these points. Now, if you want to evaluate these points,
I remember it's actually evaluate curve, not analyze curve. Okay, but let's finish. Let's listen to this person explaining how to evaluate the curve and why does it matter to reparameterize the curve.
I'm using the curve components and right click and choose set one curve to load this curve up. Now, if I do evaluate curve and load the curve into the C components, and for T, I need a parameter related to the curve domain. Now, we don't know the domain of this curve. Normally, it's somehow similar to the length of the curve, but as the information gets more complicated, let's say it's a three-dimensional curve like this, then the domain would have a different value. So first, we're going to look at the length. So if I use the curve length, because we are looking at a line, and the length of this line is somehow 40 units. So if I multiply that value with, let's say, 0.5, and we supply that into the T parameter, you can see that it's giving me the midpoint of the curve based on its length. So the beginning of it is on top. That's how I drew the curve. And the bottom of it is the end of it. Now, this will work fine when it's an arc. As you can see, we can still measure the length of the curve. The length and domain of the curve is pretty much consistent. But it doesn't work the same way when we get to a nerve curve, so you cannot use the length information anymore. As you can see, 100% length somehow doesn't go to the end of the curve. Now, we can actually fix this by doing what we do as a curve domain. So you can extract the domain of the curve, and this will give you the information in terms of the numeric value for the beginning and the end of the domain. And then you need to deconstruct the domain to extract the larger value. And then you can multiply it with some percentage, and now you can get to the end of the curve pretty pretty accurately. So now you can see that the evaluation moves pretty much smoothly. But we don't need to do any of this actually. So all we have to do is delete all of this, and you can come down here and attach the parameter that goes from 0 to 1. All you have to do is right click to C and do reparameterize. So what that does is basically restricts the domain of the curve to be between 0 and 1. So all we have to do is give it a floating value between 0 and 1. So we can evaluate the percentage along the curve. So this.
Okay, so I think that's very sort of useful. He's explaining it much better than I did. Plugging it in back in. Hopefully this works with the recording because I'm switching input sources. But okay, so listen to him also, if you have time, listen to him also talk about reparameterizing surfaces. But basically, this is what I'm going to talk about now because so evaluate. Yes, I finally remember evaluate curve, right? So what he is saying that is basically if you have a curve, let's say this curve, right? And then if you have a parameter, let's say, well, how do you, let's say in Grasshopper, right? In Grasshopper, we're doing parametric design. Parametric design means that you design with parameters rather than, let's say, you design with exact dimensions, right? So if you have a chair or if you have a staircase, then it's very simple, right? You would type in a chair, 500 millimeters tall, 350 millimeters wide. So you would already know the dimensions. But in Grasshopper, it's in a lot of cases because we are playing with parameters. We have these sliders, right? We have these sliders and we would change the parameter. So when we are designing with this, we are designing always with things that changes in length, but also things that changes in proportion, let's say. So if you imagine a chair, right, a parametric chair would be a chair that could change its width and its height and its length or all of them at the same time, right? A Rhino chair or like a three-dimensional model chair would be just a static chair. You might be able to change it slightly or you might be able to remodel it, but there is limited freedom to actually change it in different dimensions. So we would have to leverage the power of using parameters to change geometry or to control geometry. And the way that we do it is through just now he was talking about this reparameterize button. So right now you can see the point is here. Despite you changing, let's say 0.5 to 1, it will still be at the same place because it's reading the length of the curve, right? So the length of the curve is 258.632 meters, right? So in order for us in Grasshopper to correctly type the value, or in Rhino, in order for us to correctly type the value, we will have to go to 58.6632 divide by 2, right? We will have to input this to get the midpoint, 129.316, right? And very quickly you will see that this is quite cumbersome, right? And in fact, for if you have 1,000 of curve and when you don't have just only one curve, you have like 5,000 curves or you have 100 curves, or even if you have 10 curves, doing this multiplication, division is very, very slow. Okay, so people who have been working on parametric design or these kind of parametric tools are pretty clever. They came up with a way that they came up with a method what they call reparametrization. So it's parameterizing the curve itself, right? So basically what it does is when you click this button on the reparameterized curve, it will make the curve, so 1.0 or 1.00000, it depends on how many decimal places that you give it. Basically, 1 would be the one end of the curve, and 0 would be the other end of the curve. So basically, when you toggle it through 1 and 0, it would be sort of the ends of the curve. And what's neat about this is no matter what shape you give it, like let's say this shape, right? It's very hard to understand the midpoint of this curve. But when it's easy to understand the, let's say the start and end point, right? Start point is here, end point is here. But if we want the halfway point or the midpoint of this curve, by typing it in 0.5, it will actually give this to us. So this is a very good way of actually sort of it's related to the domain issue. So we have talked about domain quite a lot in previous classes. Domain is really just putting everything you have in one number line. So domain, right? We've talked about this domain 0, 0 and 1, and then what you have in the middle is 0.5. But in the middle, you can actually have as many divisions as you want. And this is the application of domain onto line, onto a curve, right? Okay, so and in fact it works with any kind of curves. Okay, like so, right? Like you can see the application of reparameterized curve from a single straight line to a curve. So now you have to what you have to understand is is going up one dimension. Okay, so this is basically I would call this 1D, one dimension, because 0 to 1 is sort of one dimension, right? You can say 0.5, but 0.5 does not have actually physical dimension. It's a concept, right? Like it's a concept in your mind. So when you say 0.5 is midpoint, it's a concept in your mind. But now we are going from one dimension to the second dimension. Okay, so this is also something that happens in every single software. So including Rhino, and every single three-dimensional software, including Rhino, including let's say 3ds Max, including Cinema 4D, including Houdini, including any type of three-dimensional software that you will come across. You will have to create a surface, and sometimes in Rhino, when you create a surface, right, you will see this sort of strange geometry or strange iso is called iso curve in Rhino. It's called different things in different software. But basically, this is an indication that it has a U and a V value. Okay. So what a U and a V value is that it is let's say it is a dimension on the plane. So we have real geometry, right? We talked about where the real geometry is. The real geometry is here, right? Like from let's say the XYZ, right? Like the XYZ point, this is 0, 0, 0, right? How do I know this? Because I know the origin is here on the origin plane, origin plane. But when things are mapped onto a surface, it has its own U, V, and W domain, which is what I've been trying to explain, U, V, and W domain. So I'll draw it now as well. So very typically, U and V is basically X and Y on a surface. Okay, so you have the true geometry XY. This is also evident on a surface with the XY. So it's basically XY plane on a surface. So in fact, I know. Let's say, let me try to sketch it here, right? Like I know the for example, right? This is, let's say this is the XY, right? This, for example, I know it's in the wrong direction because right now it's rotated. But so let's say this is the true dimension, and this point here I know by definition is 0, 0, 0, right? This is the origin point. However, on the surface, we have stuff like the 0, 0, 0 here too, right? We have the 0, 0, 0 here, but this is U, V, and W. So this is, whereas this is X, Y, and Z, okay? So basically, it is creating a geometry. You are creating, let's say, another plane that maps geometry onto this plane. And basically, this is how people, sorry, I stopped sharing. Okay. Okay, so this is how people map certain things. Let's say it will take this thing and then map it. It will take it and then using this UVW and then to map it onto this surface, right? AV3. So basically, this is how you transfer, right? How you transfer from one geometry to another geometry. Okay, so with this understanding, let's now try to let's now try to do it. And in fact, I think we have all the material except that this surface needs to be parameterized. And then that's it. Actually, I explained for half an hour. What you actually need to do is right-click this, click on reparameterize, and it should show up, right? Like if it's in the wrong direction, let's say like this, then you have to, let's say, rotate it 180 degrees. Not sure. Okay. Oh, the other way around. Okay, so 180 like this. I mean, it takes a bit of work for you to flip it in the right direction. But basically, what it's doing now here, just basically, right? It's taking this UVW here and then mapping it onto the UVW here. Simple enough, right? And then I mean, except for these two components, I mean, these two components, I already said it's workaround, right? Except for these two components and this component, you can basically be replaced with this, right? So this thing, I can I mean, I can do a 0 to 1 and then I can plug it in. So except for all these components, it's only this component that is working, doing all the work, right? So basically, it's very simple. It's just what I said, right? You put in the geometry, which is AV3, and then you put in the reference geometry here. One technicality is we have to extrude it because it doesn't understand if you don't extrude it. It asks you to give a bounding box, right? A box to map from. So it's using this box idea, bounding box idea. So we have to make the surface into a bounding box, right? We have to sort of, I mean, if you like, you can already, let's say, you can already extrude surface for it to be more simple, right? You can already extrude surface one, and then you have to cap it. You have to cap it here. And then let's say I delete this, use the reference one geometry. I already reference a box, right? It's called a boundary representation, but it's same as a box. It still works. So let me hide it. So now I'm cleaning it up, right? Like I'm cleaning it up. I have the reference box, let's say, and then I have the surface that I want it to be mapped onto, and the surface is reparameterized. The surface is reparameterized. And the box, we don't have to reparameterize because it's not a surface and it knows how to read the length of the box. So it will take, the box is already giving it domain. So it's already understanding the box as like a reparameterized object. Okay, so basically that, and then now you can exchange this AV3 thing for whatever you like, right? Like you can create curves here, and then you can make this here, and then the curve is morphed onto the piece of surface. Let me hide this so that it's easier to see. So the curve itself is already sort of, let me bake it. So I will bake it. The curve itself is already giving this three-dimensional, it's going to be projected, let's say projected or morphed onto this three-dimensional surface. Okay, so I think easy enough, right? Like very easy to understand using only one component, right? It's just a very, very useful command. Okay, now I want to actually, yeah, I want to be able to use things that I explained last week. So last week I explained to you that there is this populate command called populate 2D or populate geometry. I will use populate 2D because populate geometry might be a bit slow or might be a bit we don't need populate geometry now. We only need populate 2D because what we will do is we will be populating things on here, and then we're mapping it here. Okay, so we sort of transferring it here. So how we are going to do it is following. So please put your surface. So I hope you still have your surface here. And then you can type geometry as well. Set one geometry. So set your surface as your geometry, plug it into populate 2D, and it will already give you population onto the surface with random points, right? So random points like this. And in fact, you don't have to change the count if you don't like. If you want to keep it as default, it's already giving you output, right? And then what would happen, what you can do now is that you can let's say you can map it directly onto the geometry, right? Then now every single point that you have on this surface, on the flat surface, is going to respond to here. So what you can do that could be very neat is you can, let's say, I can do a sphere, right? I can do a sphere, or I can do some primitive shapes, and then I can plug this population in, and I can see sphere are generated here, and I can plug this in here. And so that, let it load a bit. It's going really slow. Uh-oh, did that crash my computer? Okay, that it's just slow to calculate. But you see these spheres are morphed into sort of shapes here. Let me decrease the count. Yeah, it's like populating 100. Let me just decrease it to 50 so that it might be less slow. And then, in fact, what we can do is we can have other primitive shapes such as cones and here, and then maybe I can increase the length of it to really spiky. So 5, let's say. So 5 really spiky cone, and then I can put it on, right? So now it's a really spiky tunnel towards the outside. So and then you can also can I flip things here? I think I can flip surface here. Let me see. And then I can flip it so that these things are going to poke people who pass through the inside of the tunnel or create these really pokey or furry, I don't know what material it is, but it's going to create sort of geometry that follows the, let's say, the inside and go towards the inside, right? But I like this one better facing the outside, so it looks like a concubine or something like that, like an animal or something similar. Okay, so that's it. That's just using. I mean, it's really just using this component, right? These components I've sort of defined it using. Well, I've randomized the points and then create spikes or create the cone to create geometry there. Okay, so easy enough. Right now I want to, I just deleted the cones or the spikes because yeah, those looks cool, but they are not very architectural. Okay, so now we are going into the architecture part rather than the sort of the fun modeling part, right? So the previous, I think the previous method, we can use it for, let's say, making video game characters or making animal fur, but it's very hard to use it for architecture, right? So in architecture, we have to, let's say we have to have, let's say a control, right? We have to have geometric control. Basically, what I asked you to download the lunchbox is a really interesting component. So lunchbox will be on the top tab in your Grasshopper Grasshopper file when it's already installed as a plugin. And there are a number of things that they have, but the most useful thing that I find for architecture use is this panelization, basically. I really want actually Grasshopper to include these plug-in components, and a lot of people have fought on this for Grasshopper to include it natively for, I think, more than 5 years. However, this is Lunchbox is a now a private company, so that they own their own software team, and they offer this as a plugin and not as sort of natively installed thing onto Grasshopper. So what a pity, but we can now use it using this plugin, and the plugin is free to use, but it just needs a bit of sort of installing. And we already did the installing. We already did the installation, which is the package manager. So we already installed this lunchbox. So let's say now we are going to use the lunchbox. How are we going to use it? And it is the following. It is actually very simple. Let me use the grid example for now. The grid example is very easy to understand, because the grid basically it's in here, it's called quad panels. Quad panels. And basically, this is what it will do. It will already, it will ask you for surface, right? And then it will already have U and V division. U and V division already 10 and 10 is the default. And you can change it, and maybe 10 and 10 for your case is not so good, right? Like you can see maybe 10 divided this way is okay, but you want less than 10 divided this way to get more. Let's say our goal is to get more square-ish panel. So maybe we would do 10 here and 5 here. Oh, the other way around. So I have mixed up UV. So it would be the other way around. 10 is V and 5 is U. Okay, so even 5 is a little bit too much. So maybe let's say 4, and then maybe we can divided it more, so maybe 13. I don't know how. Anyway, yeah, anyways, 13, or let's say 18. 18 is like, seems like 18 and 4. But you're free to do whatever you want. But basically what you will do here is just plug in the geometry. And we already have let's say a square-ish, or like a grid system that can be used on this surface morph. Okay, so already it's pretty useful by now, and we can now we can already, let's say when I bake it, right, we can already have when I take it out, we can already have surface panels that are individual, and that is projected onto this surface, right? So easy enough. I can put whatever on it, and in fact, I can do a number of pattern, right? I can do, let's say maybe I like diamond panels. I can put it in here, change the UV, let's say this U and this V, and then I can put the diamond panels already here. And it's already creating, I mean, maybe it's not enough. Maybe I need to increase it by 8 to 30. 8 and 30. So now I can already, when I bake it, I can already create a cool pattern like this. And then I can, what is a good view? Not rendered. But anyways, this might be a good view. But basically, I know. Maybe I have to properties. Maybe I have to turn off the ISO curve. So this would be already your geometry, and then you can make, certain ones transparent or stuff like that. You can already pretty quickly, you can get to something very architectural with a lot of control. So this is, in fact, let's go through all the, let's go through all the panels that it offers. It has diamond panels here. It has hexagon panels. It has, well, quad panels is what we just used. It has random quad panels. It has skew quad. Oh, actually, I want to try this. I never really used this that much. Okay, let's see what it does. And then plug it in. Okay, yeah, kind of cool. I mean, it's kind of cool. It's like the Herzog. Is it the Herzog and the Meuron? Herzog and the Meuron. What is it called? The stadium in wait, not the. It's not this one, not this one, not this one. Wait, where is it? This one. It looks like this one, right? Like the quad, the slanted quad panel. Wait, where is my this one? So when you bake it, you can already see that, you know, this is already pretty architectural object. Of course, this is in a donut shape, but you can see the resemblance of how these geometries are generated and what kind of technique they actually use to generate like these architectural objects in general, right? Okay, so oh, I haven't finished going through skew panels, stagger quad panel, triangle panel C, triangle panel A. Okay, these I haven't tried, but they look promising. Okay, so how you would actually use it is the following. You can actually use it for creating geometry. And in fact, I mean, by this point onwards, whatever you create here, you can start by, I don't know, you can model anything in here. And you can already, let's say I want to use Rhino only to model whatever I want to model. Like, let's say, I don't know why you would do this, but just for example, let's say not snapping, scale 1D. Let's say you have this thing and then you Boolean difference. You create something very, very strange and complicated. And then maybe I will, let's say, how do I do it? Array, it's array, right? Array, x is, let's say 20, and then y is maybe 4. No, not 7. Okay, 24, 1, okay. And then let's say I want to model this. Oh, pretty close. So I just modeled this. I don't know why you would want to do this for your project, but please don't do this for your project. But basically whatever I model here, I can set multiple geometries, hide it, multiple geometries. And I believe if I plug this in, it will take some time, but already it's kind of creating this. I don't know why you would create this, but it's already when you plug it in, right? Whatever you plug in on this surface, it will map here, and we can look at it in let's say in render view or Arctic. Yeah, Arctic. Not sure why you would want to do this, but basically anything that you map or you provide here can be mapped easily onto this surface. So, and this surface will be your EA, right? So your EA and also your CA4 assignment. Okay, so I think that's it. I have some, let me see. I have some more stuff that I want to cover, but I will also want to let you go earlier today. Let me cover that stuff first, and then I will leave. We can leave class earlier today, at around 6. But basically, what I want to teach now is how you could in Grasshopper control these panels. So the issue being is like why is this not okay, right? Why is this too elementary or too easy? That's because this does not have thickness, right? Like it's very easy to say that it looks architectural, right? Like this looks like some architectural work, but it doesn't have thickness, right? So when you build it, this will collapse, the surface will wrinkle, or the surface will not stay in this form because there is no evidence of structure. There's no evidence of thickness, right? How we can do this is the following. You can, let's say, using this, you can, oh, I forgot how to do it. You can, oh, I remember now. Okay, you can actually, one really neat thing about this lunchbox thing is it can actually give you a lot of information. You can plug into curve and it will give you curve. If you plug it into geometry, as we said, it will give you the geometry, right? So you can see that the output is the same, but actually when you give it different component, it will take different things, right? So for example, now it will give me these curves. When I bake it, let me show you what it does. It gives me 72 curves. The curves will be sort of in a panel format. It won't be sort of in a grid format with X and Y lines, right? So this is very neat for us to actually manipulate the panels. So now let's look at just having the curve. And then last week, 2 weeks ago, we used actually the same component, right? The component that we were using is offset, right? Offset, and then offset curve, right? And then we would be saying, okay, the distance needs to be negative, right? So let's do -1. So one really easy way to do negative number is you can do 0 is larger than -1. Oh, wait, no, okay. -1 is smaller than 0. Okay, so this is a very quick way to get a number slider of -1. You don't have to know this, but I just use it a lot so that I know it. But basically, you can do any negative number. So you can do negative 1,234 is less than 0. Or actually, you don't have to type 0. I believe it already will give you this number. But oh, it will actually go to, if you don't type 0, it will actually go down in number. So you still have to type the 0 if you want it to go to 0. But basically, I've generated a slider that goes from 0, that only has like -1 and 0. And then you can change it in the edit, but this is slower, right? This is slower than the method that I was showing you. Okay, offset curve, negative number, so it offsets in the middle. Then basically you can see already that okay, data structure is different, right? Look at the data structure. We have talked about this. Data being the data structure is different. So now we would have to merge it and loft it. Basically, for it to be easier, maybe I'll just flatten this, merge these two, and then actually no, I cannot do this. Yeah, I cannot do this. Sorry. Backtrack. I have to graph this. But basically, when you have to manage the data, then you have to, well, when you have to loft, then you have to actually, no, now that I think about it, let's try a different way. Let's try a new way that doesn't need data management. Okay, so this would be easier for you to understand if you are a beginner, right? So very easy to understand. You get the curve, you extrude it to the C direction. Okay, very easy. This is something that you will already do in Rhino, just extruding curves in C direction, right? No problem to understand. And then you will do offset surface, right? Offset surface distance. Oh, why doesn't it work? Okay, let's see. Data fell from BREP to surface. Okay, offset. Shit. Offset. Wait, why is it? I thought it would work, but it doesn't work. Let me see. Offset. Sorry. Offset surface. How do I make it work? Yep. It seems like I can't. So BREP, open BREP. Does it have poly surface? Okay. Sorry, troubleshooting on the spot. What if I put it into surface? Yeah. The problem is when you extrude it, it becomes a BREP, which is a boundary representation object. It's no longer a surface. And then I cannot thicken it. Let me think of how to thicken it. I can't thicken it. Yeah, no, sorry. Backtrack again. Basically, you have to offset it. You have to offset curve. And then offset curve. And then you create the surface and then you extrude it. Sorry, that's the only way. That's the only way that's the easiest way that I can think of now. Maybe later on I figure out an easier way. In order for, oh, actually, let me think. This one, boundary surfaces, edges. Okay, let's try a different way. Sorry, it's like a lot of geometry figuring out. Draft, and then merge. Okay, you don't have to understand what I'm doing now, but I'm just trying to see. Okay, perfect. But still you have to graph. So basically it's not giving you a lot of information. I'm just really, basically I am replacing loft with, yeah, you're better off with just having loft because I was just replacing planar surfaces with loft. But basically what you need to understand is you can do geometry in Grasshopper, and then you can, let's say, extrude it in the C direction like this, and then you can plug it in. And then basically you will be left with this surface here. And it will be morphed onto the surface. Something like this. And then lastly, I want to cover something. I will give you this script. I will give you I'll actually give you, I won't give you exactly this script. I will give you a more complicated script. And basically, I won't go through it, but I will use it to explain. I will use it to explain what I'm doing. But basically, now you understand that everything is like on this flat plane, and then it's going to be mapped onto a three-dimensional object or three-dimensional plane. Let me try to download parametrize. Download. Download. Okay, so I've 13 minutes. Bear with me. Okay. Let me do Grasshopper. So I will give you this file basically, but let me remember what it does. Okay. It has the cone here. Let me delete that. What I want is this one basically. So let me turn off the buildings and I will show you what it does. It's basically still mapping this surface onto here, but now it has gone to a much more, I'll clean this up and then I'll give it to you, but let me find, yeah. So basically it's still having stuff here and then having it react and then putting it into the geometry. So basically at the end, what I have is this one. And it's all basically ranging from what we had before, right? It's still the geometry, reference plane, and then surface to map onto. Basically, these 5 things below doesn't change at all, right? These things doesn't change at all. At the bottom, it's just this geometry is changing. So let's backtrack and see what is changing, right? So what is changing is basically I plugged in a new script here. A new script here. You don't have to understand it now, but this is what we call a closest point or point attractor. So point attractor is, I can't find my point. Hold on. Where is the point? Oh, attractor point here. Okay, point attractor is this one. So basically, when you change the point, the following thing changes. It will, let me stop this one for a second so that it loads faster. But basically, all the geometry follows this point, and it will calculate the distance of this point to in order to change the opening size of this. And then basically this is then morphed onto our surface here so that you would see a change in density of the structure. So you not only, so I mean, this, to recap what we have done this lesson, right? At first, we have mapped something on the flat plane to a three-dimensional plane. Okay, that's one, right? You remember the AV3 a flat plane onto a three-dimensional plane, and then we are our only variation is this geometry part, right? And then I went through how to, let's say, map geometries onto it, be it randomized geometry, randomization of points, random points onto a geometry, or random things like cones onto a geometry. And then also we also changed this to be the lunchbox panels. So mapping lunchbox panel, and then one step further, right? Lunchbox panel with sizes, changing of sizes. Okay, so in conclusion, it's just different ways of mapping the geometry. I also have some slides I was going to show you next lesson, but I figure maybe I'll show you this lesson as well. So there are a lot when you hear Grasshopper, there are a lot of Grasshopper tutorials online. A lot of it ranges from, gradient pattern. So this is when I search Grasshopper gradient pattern. And this is one special aesthetic of Grasshopper, right? When you can actually create buildings similar to this or similar to this kind of aesthetic, right? So when you go to, let's say, a building by, let's say, Zaha Hadid, or a building that has some kind of this design, you can already tell that it uses some form of parametric tool or some kind of parametric design tools to make this happen. So that this is basically covering, it's out of this lesson scope to actually cover all of these. But this is something that can you see it, or is it hard to see? Do you want to turn off the light, or no? Or turn on the light? Maybe that light was broken. 我閂冷氣，你熄咯，我都有啲凍。哦，okay, that's fine. Okay, sorry. So these kind of sort of like aesthetic really belongs to Grasshopper, and if you learn, not everyone has to learn it. Not everyone has to go through and learn it. But if you want to learn it, these are the ways of learning of learning gradient pattern, Grasshopper scripts. And for example, what I have just shown you, right? This offset and creating panels. These you have a tutorial. You have parametric patterns. You have patterns like these, and you can create it. I won't go through this on our lesson, but I'm just making you aware that there are these things that you can do with Grasshopper. So attractor point. So basically the points, they calculate the distance between the point and the point on the surface, and they will create, so these would be the attractor points, and they will create a certain aesthetic, and it's by creating the closest distance to it, and it would go through a sort of process called remapping. So it would remap the radius of the circle, and then the radius of the circle can vary based on the distance between the attractor point. So I won't go through and list out I won't go through and talk a bit, talk about all the aspects of it. But basically, this is the method that I was using to create these sort of larger and smaller holes in this instance. So I will give you the script of this one, but you would have to change it or create a new geometry and submit this as your your CA4. Okay, so this would be your CA4, and CA4 is due on November 7th. So you will have more than enough time to, given the script that I will give you, I'll give it to you on maybe tomorrow or on Thursday. So you can, change it, and then you can use this to submit CA4. CA4, you have to submit the script and also the screenshot of both your script and something like this, right? Screenshot of both your script and your components. Okay, so that's it. I will show the QR code again. So this would be the attendance for this class. Thank you for that. Sorry, I have to stop recording first. Stop, okay.